Hey, and welcome back to another episode of Awesome Apey Orb, or another development episode of Awesome Apey Orb. Tony, I see you're already in here. That's exciting. Good to go. And if you'd like to learn more game development, join the Discord. It's in the description below, or subscribe, because we're doing this sort of Monday to Friday. But last time we had left off, we had created, I believe, our 15th level, which is pretty good because we only need 20. And then once we finish up that 20th level, I think we'll just go ahead and make the leaderboard, make some UI, and that'll pretty much be it. And then we'll be able to release and play it. So anybody who has a quest or a quest 2 will be able to do that. So that's pretty exciting. But sorry, I'm on a random thing here. Cool, let's dive in. Let's make sure I had everything set up. Okay, I don't actually. Let me just open up the project real quick. So, how's everything going, Tony? Oh, you know what? I forgot to change it to... I've been meaning to set it to low latency. I keep forgetting. But whoever just joined, welcome. We are just getting things set up here. So if you have any questions, now's the time to ask. If you haven't joined the Discord, that's where we're all going to be learning game development. And it's in the YouTube video description, the link to that. Are you just in school, Tony? Okay, yeah, so it looks like we had just finished up this level 15 here, which was basically... It ended up being so complicated, but it was basically supposed to just be a memory game where you had to remember which tube was correct to go down. So let's go ahead and run that once to get us started here. And if you're new to the stream, whoever joined, feel free to introduce yourself. We're all friendly here. All right, let's see. Yeah, so... Let me reset my view real quick. Don't think you guys can see that. Okay, cool. So I'm in my ball, and I get to choose between 1, 2, and 3. So let's say I pick 3. Okay, so it looks like that was wrong because it's just going to shoot me out here, and the level is over for me. And I'm back at the start. So let's pick 2 this time. Okay, looks like that was the correct choice because I'm in the next area now. And so now I know 2 is the first tube. Let's try 1. Okay, looks like 1 was wrong, so I'm getting spit out again. So this one's kind of just fun trial and error. And I won't show you guys all the levels, but... Yeah, Tony, I need to make like a... I'm sure I can make some sort of YouTube chatbot that can basically post that Discord link every like 20 minutes or so. So that you don't have to, but... Okay, cool. So, also if you guys have any ideas for a level, I'm kind of out of them, to be honest. So we'll be kind of winging it here. So let's see, what do we need? We need to make a new scene. And let's copy, I don't know, what is 1.5? Yeah, it seems like a good one to copy. Let's go ahead and duplicate that. Let's open the new one. Let's edit it. We're just copying the scene here so we can more easily. Creative 4.1, okay, cool. And then before we forget, let's go ahead and each level or each world has its own sort of color scheme, green, blue, or red so far, and we're gonna make the last one black. So we just need to go ahead and create a new folder here, call it World 4. And if you have any questions about this, let me know as we're going along. Call it World 4, create a new material, because materials are what you apply to something to give it a certain look. If I wanted it to be wood, I'd make a wood material. But this one is going to be a black checkerboard, and you'll notice it's not a black checkerboard yet, and that's because we're not actually using a shader that is going to produce that effect. But if we go in here and we go to World 3 and we duplicate this one and then we rename it, the renaming isn't going to do anything. It's when you change the code that will actually do things. So we'll rename that to black checkerboard. This is all just a little bit of tedious work to get this set up. We'll make a folder for it called World 4. It's good to keep your projects organized. And we'll go ahead and open it up. Okay, now we've duplicated the red checkerboard. So we're going to want to go ahead and change this to sort of a black. And you never really want to go full black because you don't see that in real life. You don't see full black, you don't see full white. So I'm going to go kind of like this dark looking color. And I almost wonder if I should make the gray the white a little darker too. I think that might look cool. Okay, let's get rid of all these. We don't need these anymore. That was from another level. And hey, to whoever joined, we're glad you're here. Basically, I'm making a game called Awesome Apey Orb, and right now I'm just making a level for it. Let's see. If you have any questions, feel free to ask Tony in the comments. I'm sure he can answer them for you. But if you have any questions about the actual development of it, go ahead and just ask in the comments as well, and I will answer. World 4. Oh yeah, I hadn't set the shader. Why am I not seeing it here? Black checkerboard world space. I did save that, did I not? Let me just see if I can search for it. Cool, so that did work. Okay, so now we have this sort of... Yes, thank you, Tony. That is exactly what I'm trying to do, and we're on good track to do that. If you have any questions about how we did any of the... We have 15 levels so far, Rolly Ball. If you have any questions about how we've gotten to that place, let me know as well. So it looks like the white was a little too gray. I'm just going to make it white. It'll look a little cartoony, but make it sort of this kind of white. Just looked a little weird, I thought. Yeah, okay, so that'll be our World 4 level. And it's simple. We're just making this in a month here, so we're not trying to, we're not trying to make the next Cyberpunk or anything. What's up, Austin? How are you? I'm glad you showed up. We are on to World 4. We've done 15 levels. So we're going to go ahead and generate the lighting for this real quick. In generating lighting, basically what that means is that we're doing all the things that ray tracing would be doing in real time, but we're doing it prior to when it's actually needed. That way we don't have to do it at real time. Yeah, I guess maybe I should just make Cyberpunk. In a month, it'd be easy with one person. What's their team? What's their team size now? Yeah, 1,100 people making one game. Me making it in a month, probably no problem. Yeah, Danger Dom. He lives dangerously with the mustache, I think. Okay, so I'm going to probably need you guys' help here because I don't really have any ideas. I think what I'm going to do... I think what we're missing in this game right now is timing-based levels. So we could either do some sort of Fall Guys-like obstacle course where there's hammers swinging and maybe like a big turbine. They like the big turbine a lot. The other... And that does seem kind of fun. Actually, you know what? That does seem pretty fun. Let's go ahead and mark that down as something we'll do. Is like swinging balls, hammer sort of level. And then I also consider something where maybe we Keanu, it's fake news. It's only Keanu and his data slave. I don't know what a data slave is, but it sounds useful, I guess. Okay, so the Fall Guys type 1, that does sound pretty fun, actually. It's not, and it is timing based. I think maybe we can do another one. Oh, I was also thinking about doing, maybe I would just go full Fall Guys here. I was thinking about the seesaw level, and that might be kind of fun. Although, probably not, would it? I don't know. It's hard to say, really, on that one. But then I was also thinking, I was thinking about doing one where the railings are going in and out. And then there was that one Timur had, or Carjacker had sorry, Timur, had said where it was like a bouncing up level. Let me write these down. Let's just go ahead and make the obstacle course. We have time. So let's see here. All right, it'll start out. All right, let's start off strong here. Make it a little bigger. Connect them. Let's make another one. You know, no organization in my projects really, just kind of let's go ahead and switch that to global. Let's move it up, back, there. Okay, so that's our first ramp. Let's take this, duplicate it. This is so bad. Duplicate it, turn it around to about here. No, I actually don't really. Nah, I might as well do it this way. Turn it around and move it. Okay, so clearly I had not gotten that correct. That's okay. We'll do here. That should be good. Okay, and let me actually get the rotation on this. 180. 180. There. And let's move them both over just a little so that they line up. Sort of a simple start here. And let's rotate that down just a little bit. Cool. Okay, so now we need a propeller. And I believe we have a rotate on axis. And does that one already operate via physics? It does. It does, so that's good for us. Because then we don't need to make a new one. Now we need to make the propeller though. Then we need to actually make this propeller here. So let me create an empty just so that I can organize this a little bit better. This is really just scene organization. It has nothing to do with actually making the game. Let's call it obstacles. Obstacles, if I could spell that right. And let's make another one. And let's call it propeller. Cool. And then we'll basically want to create, I guess, a cylinder. Well, let's go over to it so we can just work here. All right, so basically we will make this cylinder, we will make its Y scale 0.3 so that it's smaller. Then we will, and that's just going to be the base. Then we will create how to make the arms of it. I'm just trying to think which shape would work well for that. I almost think just a general capsule might work. If we set it to 0.1 as well, and then just increase it in this direction. Yeah, it looks like that's going pretty nicely. Although it does appear that the capsule collider itself is having problems. So let's go ahead and remove that and do a mesh collider. And hopefully that will work for us. We'll call it wing. We'll copy and paste it. Put another one here. And this has been pretty much the story of my life on the actual level creation. It's been a lot of this just taking simple shapes and putting them together to make something more meaningful. Okay, and let's set these to floor. I know that seems like a little bit of a, that's probably not the move. Let's go ahead and add a layer. Let's call it obstacle. I don't want to just say it's a floor and then it's gonna, I mean, yeah, that'll work for our purposes, but it's obviously bad form. I'm sure you guys can even tell why that would be not a smart move. Yes, change children. Cool. Anyone who's new, feel free to grab some popcorn and ask some questions. Don't be shy. Thank you, Tony. And I agree with what Tony's saying. No need to be shy. All right, let's see. Then from there, I need to move this to where it's supposed to be. Oh no, actually real quick before I forget, let me make sure that the ball will interact with obstacle. Doesn't need to interact with obstacle, and obstacles don't need to interact with anything that's not the ball, basically. Cool. So that should be good there. And now my obstacle has the correct layer. And now I need to move this basically up here. So let's fly around. Let's fly up here. Let's do game object, move to view. Cool. And then we can just rotate this that way. And for propeller, we can add a rotate on axis. And what axis would that be? So this is the Z axis. So we will tell it to rotate on Z, and we'll give it a speed of 10, and we'll see what that gets us. But let's go ahead and put it a little bit better. Is this propeller big enough? It looks a little on the small side, so let's just scale the whole thing up. Cool. Timing-based levels are always pretty fun, I think. At least personally, for me, it's fun. I might make a seesaw, Tony. I'm not sure yet. For right now, I'm just doing this propeller. So let's just, let's not even hop in the headset. Let's just take a look at this here. And it's like a general obstacle course, if you guys have any ideas on... Oh, man. Alright, that's one way to make a propeller. First of all... Oh, you know what? I have global. I have it set to global. What I needed it set to was local. So you see locally, this was always the case. When you change this up here, global and local, you're just changing your reference point for editing the scene. You're not really changing anything about the object. So if I want to just move it based on like global position, I use this one. Globally, this direction here is right, and globally this one is forward. But locally for the object, upwards was forward. And that's what we did here with the Z. So we need it in the Y direction, actually. You'll see this here. Very cool. All right. So let's go ahead and restart. Let's make this Y, and then let's make this 30. And we know this will work now because we just saw it, but... Okay, cool. And then let's... Basically gonna copy all of this. I'm gonna move it all out, and let's do one more propeller jump. Do one more propeller jump, and we will make this one, I guess, 60. Basically just something faster. Still looks a little easy. Let's make this... Okay, yeah, that looks hard. That looks difficult, and then the first one is probably a little too easy. Let's make this one the 60, and let's make this one the 120. And then let's see real quick if that's even possible. And real quick before I forget, I was facing the wrong direction. Let's just go ahead and take the player spawn. No, that's correct. I must have just been facing the wrong direction somehow. Okay. Okay, so it's a lot steeper than I thought it was. Okay. And let me make sure that you can actually hit this propeller. Okay, you can. Okay, I actually was not doing this based on physics. So let me see if we can do that real quick. Where did we do this rb.move rotation? Cool. Well, let me put another... I'm not going to make a whole new script. I'm just going to make a new enum. Yeah, it does look it's a little easy, but the level is going to be longer, so maybe that's fine for now. Type, and we'll call it physics or transform, and then we're going to do the same thing here. And we're going to set the type. And we're going to set the type to be type.transform. And that's so that all the other scripts that have been using this so far don't get messed up. If type equals type.transform, do this one that we had already created. And if not, then we'll do the new one based on physics. Just so that the physics, when you interact, are better, basically. Because if you're trying to make a game based on physics, you want things to move via physics. You don't want to just like move them as you please, I guess, which is kind of what this is doing here. So we'll say else. Cool. And then we need the start. I wanted to call it RB. Okay, cool. And then we'll again do this check here, because if we're doing it based on the transform, if we're doing it based on the transform, we're not going to need the rigid body, and it probably won't be on the object anyway. So we'll want to check first before we just try to grab it. Then down here, okay, so now in here, this is the physics approach. And if else statements, they basically say like, when you're running this code, if this is true, if that's true, do this part. If it's false, do this part. So just if or else. Kind of makes sense, I think. Okay, and then this we'll want to copy most of, because it'll be important as well. And I thought that I needed to use fixed delta time, but I saw a Unity script put out from Unity that was doing something in fixed update, and it was still using delta time. And if you are questioning why we're multiplying by delta time anyway, feel free to ask. Euler angle velocity, okay. And then we'll want to multiply by speed. Okay, and then these ones, basically, we'll want to say Euler angle velocity. We're going to want to set the rotation based on what axis you do. Vector, and let's set it to 0, 0, 0. And then we'll do vector 3. See, it doesn't, this variable here does not exist yet. It's created down here, which we needed to get rid of anyway. So it just doesn't exist, so the program doesn't know what to do with it. So you have to create it first. And you'll see those errors will go away. Cool. All right, so if in the x direction, put it in x, if in the y direction, put it in y, and if in the z direction, put it in z. We needed to give that a value, and that should be good. So we'll see if that works. Hopefully it does. And so we'll take these and we'll set it to physics based, and that should be good. So let's, but first we need to add a rigid body to this actually. Set it to kinematic, take off gravity, give it no drag, interpolate it, and make it continuous speculative. Continuous speculative deals with rotations better, and because this is rotating, we're going to turn that on. Interpolate makes it look a little better, basically. It makes it look so that it's not, you can't really see it unless you were playing it, but basically the propeller kind of looked like, it didn't look like a smooth sort of rotation. Okay, so it's a lot faster, first of all. So let's go ahead and make this not 100, but 1. Okay, now let me check that. Yeah, and again, the whole reason we did this was because if you're making a physics-based game, you want everything to act on physics, not on And it does look fairly smooth now. It's still got a little bit of jitter to it, but not so much that I'm gonna worry about it. And let me see if I can hit one of these. Should hit this one here. Or totally miss it. Alright, so it turns out it's actually harder to hit the propeller. It's actually harder to hit the propeller than it is to make it through. Okay, there we go. So it does work well. Okay, so let's see now. Let's go ahead and make a material for these propellers. Let's just make it, essentially we'll just make the base black. The base black, and it's a little smooth. Let's make it more matte. And then, cool, and then let's make another and call it dark blue, subject to be purple from my color blindness. And let's make it blue, dark blue. Okay, that looks a little ridiculous, I'm now realizing. Tony, when you say make it 2-speed, what do you mean? Like it switches speeds randomly? Okay, so that looks a little weird, I have to say. Maybe if I make it darker. Yeah, you know, good enough. Okay, cool. Yeah, let me know what you mean by 2-speed. I mean, I certainly could make these. No, not quite. Not quite. Not quite. Could at least make them a little thicker. Oh, I see what you're saying. Make it this. You're saying this value here. You're talking about this value here, right, Tony? So we can increase the speed just via the speed variable, because this value here is going to get multiplied by the time and the speed that we set. So we don't need to change this. We can change the actual speed though. um, the speed value on the script, and that. And let me just do this real quick. Cool. And then, yeah, so this would be, you change the speed here. This is the, and the reason it shows up there, Tony, is because on this script here, this rotate on axis script, I have created a public, meaning you can see it, variable called speed. And I set it equal to 2 initially. And that later will be used to multiply against how fast you rotate. So we should be able to change it here. I agree, it's a little slow. Let's set this one to 100. This isn't the full level, this is just kind of the warm up to it. So we'll set that one to 100 and this one to 150 maybe. And I think that will be fine. I consider maybe that should be a little harder. Okay, I was going really slow apparently. Okay. All right, cool. So it seems hard enough. And then, I don't know, what do you guys think I should do next? I guess over here, let's do the, let me think here. I'm thinking the swinging mallets or some sort of swinging item, but I'm trying to, or what else do? What other kind of stuff happens in these types of things? Yeah, let's see if we can do a seesaw. Let's see if we can make that happen. We'll just do like a general obstacle course level. Well, we'll make it dark blue. We'll even raise that a little bit. And here, we're basically going to need to give it a hinge joint. And that actually looks perfect. We'll tell it to interpolate and we'll do, I guess, continuous dynamic. Although it does have rotation, so let's do continuous speculative. And keep in mind that these come with performance implications. I think if you had like hundreds of objects all doing physics, it would matter. I don't think it's going to matter with like 4 objects doing it. Especially not with simple shapes like this. This one's just a box. So let's take a look here. I believe that should work. Let's... Don't know why the finish line is under here. Okay. Let's move the player spawn out over here. So that I can test this out. And so what I did, may or may not work, was basically they have this script already written for you. It's called hinge joint. And it allows you to put an object on a hinge, which is basically this axis right here. And so it should rotate along that. And then we just need to make it floor. It already is, okay, and it should be good to go. So let's see. Tony, aren't you at school? How you making popcorn? Okay. Oh. And it's still going. Maybe I can time this. Oh. Okay, so essentially it does not have enough. Let me see, there's got to be a, what would that be? Its resistance to movement isn't very high. I think I might just be able to increase the mass. Let's call it 20 and see what happens. Trying to figure out how to make this a little harder. Not that it necessarily has to be. This could just be a speed one. I think that if I make that higher and make you wait a second, it should make it a little bit harder. Alright, good enough. I think I was close to not beating that right there, so that'll be fine, because you're basically, the difficulty of the level, as far as I can see, is basically going to be, like, none of these by themselves are that difficult. It would only take you a few tries. The difficulty will be in the percentage chance of you passing all of them at the same time. And basically, like, let's say this one's got like a 50% chance, and then this one you have a 30% chance. That already puts you down to a 15% chance of beating it, right? And then let's call this another 50. It's already like 7% chance of getting through the whole thing, essentially. And of course your chances will increase as you learn the level, but that would be your, like, your base first time trying. There's like a 1 in 10 chance that you'll all get through it, which isn't bad, I don't think. And then let's go ahead and go into prefabs. Take this object called seesaw, and let's put it in level design. And then let's go ahead and take these objects as well and put them in level design in case I want to use them later. And maybe we... No, okay. No, I'm fine with this. And now I'm thinking we do just a final little gauntlet here, basically the something swinging. We'll just have like 4 things swinging, and that should be good. And now I'm just trying to think how I want to do these swinging objects. Either, so a pendulum swinging is a harmonic motion, and when I say that, what I mean is it's like this. It follows a sine wave or or a cosine wave, something like that. And so I could model I could basically make a script where I take it and I just rotate it based on that harmonic motion, just using a sine, like some sort of sine function. I'm wondering if there's an easier way to do it in which I basically just use like a hinge joint like I was using here, because you can imagine I can put it on a hinge. The problem is it will want to slowly. You know what? Actually, that's not true. I think I can just do a hinge joint. So let's make this mallet. Basically, let's call it mallet or mallet, as the French say. Mallet. There we go. And let us put under it I guess it would just be a cylinder. Did I make this floor? Let's make an obstacle just to be... Okay, mallet, cylinder. Let's go ahead and make this longer. Cool. I really have no reference to how long that is right now. Okay, so not the longest. And let's make this 0.5, 0.5. Maybe that's a little too long. I don't know, we'll see. And then on the end of it, we'll want to create another object. It'll just be another cylinder. And we'll call it, and we'll call this one the head of the mallet. And we'll also have a capsule collider, cool. And it will also be an obstacle. Let's go ahead and make this obstacle 2, just in case you jump up and hit it somehow. Okay, and then let's rotate this direction. It's giving me some trouble. Take it out real quick. We'll set it equal to 1, 1, 1. We will... Sometimes when you put an object under another object, it scales it improperly. Depending on if this object had a weird scale. Like, because this one had a weird scale, when I put it under... Or when I tried to rotate it while it was still a child of that object, it gave it... it really messed up the scale dimensions. However they're doing it. So, real quick, we'll just make this bigger. So that's a big old mallet. Let's make it even, yeah, just huge mallet, basically. And then we'll put it back. Oh, okay, I was worried about that. Okay, we're not going to put it back, actually. We are instead going to move... We just need to do some resetting here. This mallet, we want the pole to sit, what, -1? Okay. It seems to be taking its scale into account, which I have to say is a little surprising. What are we looking at here? Okay, so let's say that this is 8 meters. Then this should be -4. We're trying. I'm basically just trying to place the pole such that when I put a hinge on top of here, it'll be right at the top of that pole. That way I don't have to put this head under the pole, which, as you can see, messes its scale up, which is not good for us. Back popcorn has some issues. No problem, Tony. I'm just trying to place this pole correctly, and for some reason having some trouble with the math behind it. It is a child of the mallet, so it shouldn't be... Okay, there we go. It really should be -4, but as you can see, that's not... Let's move this out of the way real quick. Whoa. Move that out of the way real quick so we can see. We have this... What is it? Let me just place it by hand and then let me see what value I'm getting and try to make sense of it. Okay, so that's pretty much perfect. And so it's saying that it's... Okay, so it is just -8. It must be that if you make the scale of a cylinder, the cylinder must originally be 2 meters tall. I was going under the impression that it was 1 meter tall. And because it's 2 meters tall, the whole thing, when I scale it by 8, if I make the scale 8 instead of 1, it's going to be 16 long. So to center it on its parent, you're going to do -8, half of 16, -8. And that should be perfect. It is. Okay, and then this head will want to go down -16 for the same reason. And now it should be placed nicely. And then here we'll want to do a hinge joint. It will use gravity, it will have no drag, and it will again be, let's call it 5. Well, let's call this one 1. Interpolate it, continuous. It's not attached to anything. It is currently, the hinge that it's swinging on is currently facing this direction. If you can see it, it's small, but it's there. And it gets smaller the closer I get to it, but it's facing this direction. So let's go ahead and see if we can change that to its, what direction do we want here? It looks like Z. Okay, and that should be good. Let's give it a mass of 10. And let's see what happens here. Then let's take it and we'll start it out at a certain angle. Let's call it -50. And it shouldn't slow down. At least that's what we're hoping to see. It doesn't have any drag on it, angular or regular. So it shouldn't slow down. And it doesn't look like it is. You see the Z rotation, we had set it to -50. And it looks like it's still going up to like 49 points. Oh, that one looked like 48. So it does appear to be slowing down somewhat. Maybe. It's hard. It's kind of hard to tell. Let's give it a second and let's see what happens. It's still going up to 48. It's possible it has like an extremely slight amount of drag to it. No, that one didn't break 48. And that one didn't break 48 either. So somewhere it's slowing down for some reason. And this is kind of what I was worried about here. What is free spin? Yeah, so at this point it's obvious that it very much is slowing down. It's only going up to 45. So it must just be some... I guess you would call it, because this object does not have angular drag or linear drag. And for those of you who don't know, drag is basically a friction keeping an object in motion from staying in motion. So like the drag that air puts on a car is what slows it down. If there was no force making a car slow down, it would just keep on going once you took the gas off of it. But there are several areas of drag that are slowing it down. But because this has no drag, it shouldn't technically slow down. So there must be something in the unity, excuse me. So there must be something in the unity physics system that is causing it to do that. And now the question is really just is there a way for me to I wonder if there's a way for me to keep it in motion, essentially. You know what I wonder? I wonder if I can do negative drag. This actually wouldn't make much sense, but I'm curious to see if I can do it. I wonder if it'll speed it up. No. Okay, so they make sure you don't do that. Okay. So then our options are write the script ourselves, write the script ourselves based on harmonic motion, or figure out why this is doing this. And I don't know if there's going to be a good answer. It is, yeah. It is the same level, so the wind turbines are back there. Now I'm just putting a few mallets, and then it'll be the end. Essentially, okay, let's see if we can make the target velocity that, and let's see if we can really up the force here. And then let's play it again. And I'm just curious about how the hinge joint works in general. Does not actually appear to... I don't know what target velocity is supposed to mean. I've never used it because it does not appear that it's doing anything like that. Okay, and I think at this point we would just write our own script. It was a good try. I thought it was going to work, but it looks like there's some... Because basically... Let me think if there's a simple way to explain this. Whenever you're doing a really complex math problem that you need to solve for something, like let's say I'm like looking for what the output of this function is, or I'm looking for what variable I need to make a function work, or what parameter I need to make a function work, or something like that. You have two options. Either you can solve it analytically, is what it's called, where you get the exact answer, or you can solve it numerically, which is where you just use a lot of computation, which is what computers are good at with their like 4 gigahertz CPU, you know, to find an approximate answer. It's not the exact answer, but it's close. And so that's what the physics system in Unity runs on, a numerical approach, where basically everything that they do is kind of approximate. It's like, yeah, it looks basically real. It's not fully real, and sometimes we mess up, but for the most part, it works. And that's kind of what they do. And it seems that we ran into an issue with the numerical method where basically basically it just isn't precise enough to keep that hinge swinging. Let me check online real quick before we do the harmonic one. If anybody else has messed with this. Old topic, use motor would help, I think. Yeah, see, I did that too, and it didn't work. Due to the way Unity's physics operates, there can be a loss of kinetic energy over time. So that's exactly what I was saying. Okay, and this is also what I was saying, that we would have to implement it directly. And it looks like somebody has already created this for us. I'm a little curious about this. Okay, this is a little much. I was curious what he meant by fix the time step. Cool. And so this is going to be this is probably going to be a lot better than whatever I was going to write. So let's go ahead and just use their code. And what did he call it? Pendulum. Okay. And we'll see if we can make that work for us. Create a new script, call it pendulum, because that is what he called it. Open it up, paste his code. Cool. And then we'll see if we can make that work. We will get rid of this hinge joint, and we will add pendulum. The pivot is going to be mallet. The bob is going to be the head. And let's give its mass 5. I am a little worried. Okay, well, let's take a look at it. Okay, yeah. So I think because I probably don't want them childed either. Let's see what that gets us. Which looks pretty good, honestly. So let's, obviously it has some problems. Oh, my bad. I meant to put the pole under this, under the head. Looks like it has some problems, but nothing that we can't fix, I don't think. Let's look at what the mallet is actually doing. Is it turning? Sorry, the mallet being the object that's the pivot point. It does not appear that it's turning. So we'll just basically have to write our own rotation code here. And it looks like it does not slow down, so that should be good. And now the new question becomes either use their code or write my own code. His is a little heavy, maybe. I was really just going to rotate it. Like, I wasn't really going to do anything crazy. I was just going to rotate it based on the sine function. but this will probably work overall. And you know what? Instead of dealing with all that, instead of dealing with a lot of stuff here, let's go ahead and just make this head a sphere instead. Give it a sphere collider. Now it's kind of like a ball and chain. But that's still going to give us that behavior, which is cool because now the ball is working. All we need now is for this pole to look like it's working. And I almost wonder if we can even and how would we do that is the question. Okay, sorry, give me 1 second here. Not what I meant to do, sorry. Let me get this out of here. Let me put the pendulum under here. I'm trying to get the parenting transforms correct here. Okay, cool. And then let me take it out again. And now all of this should go under pendulum. And now when I place the pendulum, it will place it correctly. Okay. Okay, cool. And now there's just still the problem of this swinging of this pole, essentially. And I think what we can do is just basically, okay. Let me put the pole under it. Let me, actually, I'm basically going to try to make it so the pole is out on the balls. So the pole is out on the ball's forward direction, and then have that ball always look at the mallet. That way it's always kind of pointing the this pole at this central point here. And I'm just trying to figure out if there's a quick way to, I think there might be. I think if I make a new object, call it handle, and you've seen me do this several times if you've been watching. Put it under the pole. Make it like this. Cool. Then take the handle out. Put the pole under the handle. And move the pole. Well, first of all, set its rotation to 0, then set this to -8, and it should be right at the handle. Move this out, take this handle, set the rotation to -90, 90, and now at least this handle is pointing along that pole, and then we put the pole back under it. Then, sorry, I know this is kind of crazy. Then we take the handle and we put it under the head, set its position equal to 0. Then we take its rotation and set that equal to 0. Okay, cool, it's coming together here. Then now we have basically this head looking that direction and the pole doing the same. We can just go ahead and get rid of this handle now, I believe. Then, what is that yellow? What is this? Oh, it must be, it's coming from the pendulum script. It's coming from this script here. Okay, and then basically we need to take all that, and I think that's pretty good. Now we just need a script for, I have like a look at script. Okay, I do not. Let me make that real quick. And all this script is going to do is make an object look at another object. And we'll make it public so that we can set it in the inspector. Public game object, look towards. And then we will want to, in here, say transform.lookAt, look towards. I think this should work, but we will fix it if it doesn't. Why do I feel like that's not going to work? I'm not quite sure. Let me check. Let me see what happens here. Make sure to set it. Okay, and it appears to be working pretty flawlessly. Now really I just need to move this pendulum up. Since when is the pendulum over there? Don't know how that happened. Let me see if I can... How did this happen? I'm fairly certain I set it so that mallet would be right where the... Because mallet is sitting right here. It's parented under pendulum. It should be sitting right on the pendulum. And I don't know why it's not. Yeah, you're good, Tony. No worries. And then the head, we can go ahead and move to something like this. And I think I'm going to have trouble here. Yeah, I shouldn't have done that. Okay, let me think. Because now the pole is too long, it's basically like kind of, if the pole is here, it's going to rotate essentially incorrectly around this pendulum. This is a little annoying because I had it so nicely. Cool. Well, that's okay. We'll just set it like this. And let's see if that's the correct height. Can't tell how close it is to the ground. It seems close enough. Okay, cool. And let's go ahead and take the player spawn. Well, first let's put this under obstacles. And let's get the spawn. And let's move it over here so we can test this pendulum out. And welcome to whoever joined. We are currently making a level for Awesome Apey Orb. It's kind of like an obstacle course level. Feel free to ask any questions about it. And I'm just testing out that this pendulum works. Oh wow, it looks pretty menacing, I have to say. Okay, so it's too high off the ground, it looks like. I'm also not completely convinced that it's centered. Okay, cool. A little too high off the ground. We just need to do a slight adjustment here, and then we'll test it again. This pendulum, we will move down. Let's call it 1/2 meter. Let's do it using math just to make sure we get this right. When you do things visually, sometimes it can be a little difficult. Okay. And let's go ahead and test it again. It still looks a little high. Is it? Okay. Oh, Kenna's here. Hey, Kenna, what's up? If you have any questions about Awesome Apey Orb, let me know. I could have sworn it was just slightly rotating, like in a circle. But I guess that's not really how that script works. And let's move it down another 0.5. Sorry, this is a lot. So sometimes this is classic. The level just ends up taking way longer than maybe you would think originally. Yeah, I mean, there's definitely something. Okay, so it turns out that whatever script they made just does not work in general. So this is a classic game development where you try several solutions until you find the one that works, and you end up having to do it a few times. Let me grab some water real quick and I'll be right back. So we're going to write our own script now. These other ones didn't work. That is, I mean, that's just one of the frustrations of game development, but you'll get used to it. So it just kind of is what it is. Especially for something as simple as a pendulum. I should have just started. And this is kind of why people end up just writing their own stuff for a lot of things, is you get tired of because that could have been quicker, what we just did, or it's slower. It's like when you wait for a bus or you just walk there. You know it's going to take you 8 minutes to walk there, but the bus might take you 4 or it might take you 16. So it's kind of just what you want. Let's see if we can quickly figure out how to write a script here that we'll actually... Now let's just delete it and recreate it. And we'll try to use a sine wave to do this. I'm not quite there yet in my head on how it would be written, but let's call it pendulum. And basically what we're going to do here okay, not quite the color I want. Okay. And sorry, just a little bit of setup that I should have had done. Okay. Anyway. Sorry guys. Everything is wrong. Why is it so bright? It's not grabbing the color correctly. Alright. Anyway. Alright, this is what we're drawing on. Cool. Oops. Sorry guys, we're having some serious technical problems here. By technical, I mean my knowledge of GIMP. So, essentially, we have this pendulum. If I will write it. We have this pendulum, and it moves like this. Go forward a little bit in time, and now it's over here. It's rotated basically through this here. So that can basically be seen as a sine wave with this value being its rotation. Basically, at here, it's right in the center. It's right here. At here, well, actually, right here, it's right in the center. Right here, all right, never mind. I'm done explaining because I'm having technical difficulties. So let me just take a look here. Let me see if I can just draw this with my brush. Basically, what I'm trying to say is if you have a sine wave, the position of the pendulum, like where it is along these many dots that it can be while it's swinging, roughly or exactly correspond to dots on this. And you can see that basically on the sine wave it slows down as it gets to the top, then it speeds up, slows down again, speeds up, slows down again. So the trough here corresponds to one of the points up in the maximum swing, and the crest corresponds to the other. And then right in the center, at maximum velocity, you have the center of the pendulum swing. So we'll see if we can take that math and do something with it here. Sorry about that. And basically the way we'll do that is we'll grab this rigid body, RB, and we will And in here, let's get the sine value. And that's going to output, well, we'll say that in a second here. We'll multiply it by speed, which is another value we're going to want up here. We'll make it public so that we can set it. We'll go ahead and comment that those are internal. So this is going to give us 0 to 1. Cool. So then essentially, sorry, not 0 to 1. It'll give us negative 1 to 1. So then we need to find a way to map that to a rotational value, essentially. Like, because negative 1 to 1 is not a rotation, and I need to set the rotation of the object. So then eventually we're going to do move rotation, and we need a quaternion. So I wonder if rotate on axis will have any findings for us. I'm wondering if I can do something like creating this vector here based off the sine. So it would, this, whatever this is, would be the sine value, and then would be the sine value, and then rotate the object's rotation by that. And I think that that might work in some sense. Let's see if we can make that work. Angle, we already multiplied by speed. Cool. Sine of 0 is 0, so it'll start in the center, and then, yeah, let's see what happens with that. Probably is not going to work. Let's see though. Let's go ahead and turn that script off. Let's remove it actually. Let's get rid of this. Let's take this mallet object. Let's put the pole under it. So it's a 0, 0, set this to -8, right? Now we're kind of back where we started with that, and then we'll see if we can remove that. Give it our own pendulum scripts. Make the speed 10. Tell it that it's kinematic. Okay, and it does not appear to be doing anything really, and that's okay. Let's check it out. And that's because we never set the rigid body. Simple mistake, but common. I forgot to actually get the rigid body itself. So this value here never had anything because I never set it, which I'm doing here. So when I tried to move the rotation down there, nothing was happening essentially. So let's see if we can get something out of that. And it looks like we do want this in the Z direction actually, so let's put it there. I still am dubious as to how well this will work. It actually does not look terrible. That's actually not a bad start. You can see that it is doing a little bit of a pendulum. It's like the world's tiniest pendulum right now. And interestingly, the faster I make that speed, so this is really not how you'd want to go about it, but I think this will probably be good enough for our purposes. Basically, we get the sine value, which is that wave that we were talking about, and then we create an angle based on the magnitude of that sine value, or a like delta rotation, so how far you should rotate. Then we make a quaternion out of it, and we move the rotation basically based on that. So I think what we need to do is create another variable called public float distance. And we're just gonna kind of manipulate this a little bit. We're gonna multiply this by distance. And that should fix our problem. And then we really just have to hope that the collisions work nicely, because it wasn't working nicely with that other pendulum script. So you see it's not moving because the distance is nothing. Then you make it this, you make it All right, cool. And now it's like the world's fastest looking pendulum essentially. But it does look like it's working. Although actually it does appear to have some artifacts in it. You can tell that it is, you can tell that it's not always staying centered. I don't know that I actually care about that though. Like sometimes it comes over here and just swings back and forth here. Let's call that like a fun... Oh, sorry, it's because the distance is so big. Let me start this over. Oh, not position. And let's go ahead and now that this is... Yeah, cool. Because the cylinder was always cooler, it just was giving us trouble. And let's go ahead and just give it a mesh collider. Let's set this distance to 100. Okay, so not quite. Maybe I can just get away with not multiplying it by time dot delta time. Again, not something you want to do, but I'm really just trying to get this done. I'm not trying to... Oh, wow. I'm not trying to create the world's greatest pendulum script. It's actually not bad. That's almost interesting in its own right, because you always see pendulums. You don't really see these like swinging. I'm gonna keep it like this actually. That's kind of funny to me. You don't see a lot of like hammers just trying to hit you. It's kind of an odd movement. Okay, it does work, so that's good. And let's see. Alright, looks like you need to have it set in the beginning or else it's gonna mess up. Let's go ahead and set this rotation to -10 actually. Set the distance to 6, and let's see what that looks like. Huh, suddenly... I pretty much see why that's happening, but we don't really need to go into it. There we go, perfect. That's a perfect swinging mallet right there. Perfectly horrifying mallet. Okay, and after an hour of trying to make a mallet, we have done it. And I'm actually pretty happy with it, so let's say it was worth it. Now all we need to do is give it a nice color. We'll just give it the same. We'll call it Black Death. Well, I guess that's the plague. We'll call Big Black Death. Well, let's not call it that either. We'll just call it the hammer. Okay. The hammer sounds good. Now let's make it a prefab in case we want to use it somewhere else. And now let's make a row of them. This one will go here. Yes, this is the way I coded it. It's extremely unflexible. Like I can't make... Like I really can't... I can't like set them to different rotations. I mean, I guess I could... All right, let's try that. Oh. Oh my goodness. Okay, so this is actually going to be pretty tough. Alright, I might have accidentally made it too hard. It's such a weird movement. It's just totally not something you're used to. It's hard to read it. Like, you think when it comes down that you can go, because it's going to go past you, but it doesn't. No! I just need to make sure... I essentially just need to make sure that it is possible... to get past these three. Oh, wow. Oh, no. What happened? Oh, dang it. Okay, cool. So it's possible. And with that, I think the level will be done. What are we looking at here? We still have like 17 days left, technically, for this game to be finished. So we can pretty much keep going at this pace for the levels. We can see if we can make them all a little bit interesting. Okay, so we need to move the player spawn, I believe, just back to 0, 0, 0. Let me go over there. Yes, good. And then we need to make the finish line A, 0, B, over there. Actually, this needs to be 180. Okay, cool. And let's actually, real quick before I hop in there again, let's see where the fall boundary's at. Take a look at it and essentially move it up to right below. That way you don't have to wait too long if you fall off. And then we will hide it again and we should be good to go. Okay, so maybe it's too hard. Let me play it a few times. Oh my goodness. It's certainly not impossible. Okay. Oh no. Oh no. Okay, let me try this one more time. Cleared. Should be good. Okay. Oh, found a bug. Okay. So it's good that I tested it. Whoop, oh, dang it. Because that needs to reset. That needs to reset its position when you fall. And now I'm wondering if there's anything else like that. I guess not. Scripts. Level design. Let's call it reset on spawn. And then we'll say that this script basically resets the object's rotation and position when the player respawns. Cool. And then we'll basically need to check if they've respawned. So in here we'll say, what was it called? Spawn player dot on respawn. And we'll want to add respond. Or we'll add reset actually. And if you weren't here when I set those events, basically this happens when the player respawns. And so I'm adding my own function to it saying, okay, if he's respawned, I want you to call reset. And then that doesn't actually exist yet, so we need to create it, and we'll call void reset. And in here, you'll say transform dot position. I will make it a little bit more flexible. Reset rotation. Basically will allow you to specify if you want to reset your rotation, position, or both. Position, then internally we'll have a vector 3 OG rotation and a quaternion, because that's how, oh my bad, OG position, OG rotation. And then basically in start, which is called when the game starts, we'll say OG position equals transform dot position, OG rotation equals transform dot rotation. Cool. And then we'll say if reset position, transform dot position equals OG position. And that's only if you want it to reset the position. If reset rotation, transform dot rotation equals OG rotation. Cool. And hello to anybody who just joined. Looks like we got somebody new. We're making Awesome Apey Orb. It is a VR platforming game in which you roll the ball. And we are pretty far along. We're just making levels now. We're actually making the last set of levels. So if you have any questions, let us know. Okay, let me take a sip of water. And that should work. So let's move the player spawn back over to this ramp so that we can test it out. And then on here, we're gonna put reset on spawn. And we do want it to reset the rotation. The position is not important because the position itself does not change. Hopefully you did well, Tony. What was it, a math test? I don't know why I assumed math. I think maybe you said that. Okay, so let's see. So you move it. Then you fall off of it. And it's back to where it was. Very cool. And it's done it again. Okay, very cool. So that's good. Tony, 75%. What math was it over? Okay, let's see. I'm kidding. If you feel that's the if you tried your hardest, then 75% is good. Is 75% a B in Canada? Okay, so we have finished up this level. Whew, so let's... I actually would rather that this is just... I'd rather that was black. And I think I'd rather that they were just pretty much all black. I don't think I like the dark blue. So quickly I'm going to change that. Just a personal preference, really nothing to do with the design. It's a B or it's a C+? Is it like a rolling average? Like it depends how everyone in the class does. Like if the top scorer gets like a 90, then it's all moved down or something. All right, cool. So now let's create another level. Duplicate that one, open it, rename it 4-2. Reload it. Generate the lighting. Well, yeah, we do want to generate the lighting for it. See, it'll make this folder here. Very cool. And now we get rid of all this just like before. Cool. And real quick, we'll set this. All right, cool. And then let's see here. I'm gonna come up with a new level. All right, Timur wanted us to make a bouncing level. Let me see if we can do that. So I guess we'd need a platform that basically when you step on, or when you hit it, it bounces you. I'm just trying to think real quick how to do that. The first thing that comes to mind for me is... First thing that comes to mind is basically I have an object that when you collide with it, it just... It takes your... You have an object that when you collide with it, it changes your velocity to facing away from it at a certain speed. My reservation on that path is that it won't really matter how fast you're coming down when you hit it. I wonder if I can do it a different way. I wonder if I can, again, just do it with preset things that they've made. Let's go ahead and duplicate this. Let's call this one like trampoline maximum. And I wonder if I can set the bounciness to 1.2 or 1.7. Let's call it 1.7. No, okay. I can't. Because I was thinking I could just bounce it a little bit higher than it landed. But I think I can pretty much do that in my own script. I think I can do that pretty much just fine. So let's get rid of this. All we'll really have to do is take into account the what am I trying to say here? The velocity of the ball when it hits it. So we'll see if we can do that. Let's take this. Let's say you walk off a little bit. Let's make sure the fall boundary isn't in my way there. It's not. Okay, let's say you walk off, and then we're going to need to make a script for level design, and we'll call it trampoline. Called trampoline, and it all increases the, bounces an object that hits this object, in that it increases its original velocity. Yeah, let's say velocity. Okay. And then here we'll want to use on collision, void on collision enter. We'll collision to call. Okay, and then basically, while we're writing this script, I'm not so confident about this script that I'm just going to try to write it all right off the bat. Although I think, let's go ahead and just print the relative velocity. Or let me see what you all have in Collider. Number of collisions, friction force sum, contacts. Okay, it looks like we might be able to grab their rigid body. This is probably how we'll want to do it. We'll do, cool, because I don't want their relative velocity. If I was going to use the relative velocity would technically work because the platform is going to stay still. And so when it hits it, the relative velocity is just going to be the velocity of the object hitting it. But instead, let's go ahead and get this one. So now that I'm actually able to access that, and I know that I can, I think we can just go ahead and change it. Okay. So let's call it, my parents got mad at me because I did bad, so they take away everything so much from my dream. Wait, are you saying they like instantly got mad at you? Like, oh, because are you at home right now or are you doing school from home? So they were able to instantly see. Oh, so you had to leave, so you have to leave the stream as well. I see. Oh, Tony. Practice your fractions and then come back. But that's fine. You know, gotta respect your parents' wishes, so. I'll see you later. Practice some fractions. I use a lot of fractions in game development, so it's not useless. Cool, so I think basically we'll just want to say let's try this. Rigid body dot velocity equals, all right, first let me store this. Velocity equals collision dot rigid body dot velocity. Let me store that so that I don't have to keep writing that out. And then I'm gonna say the new velocity is the original velocity x, and then velocity y. And it should be noted that this script would really only work for objects that you jump on. It's not going to work for, like, if I throw a ball against a wall. But that's okay because we're not using it. Oh. Nice, Tony. But are you at home? Are you doing teleschool right now? Or are you like actually in school? Let's say that it's your velocity in the y direction is going to be negative. So you basically need to give it that same velocity upwards. That's going to be a perfect balance. If it's coming down with the speed of 1, it should go up with the speed of 1. But I wanted to actually increase the speed a little bit. So I need it to go down. I need to basically set it equal to the negative velocity. So now it'll be positive 1. But then I actually need to add a function of the negative velocity. Well, let's give it a bounciness variable. Times the bounciness. And then we'll do velocity.z. Okay, cool. And then we'll make that public. And we'll just go ahead and give it a range of 0.0121. Just because I don't think we'll want it to be double bouncy. Okay. So that's how you instantly knew what you got on your test, and also I guess your parents would see it instantly. They're not mad about the 75? They don't care? Let's do 1.5. And let's just see if that works. Sorry, controllers needed to turn on for a second. Okay, it didn't quite work. Or at least it wouldn't be a very fun trampoline. So let's see if we can figure out what happened there. It should be calling here. Let's make sure that it is, though. The script is on it. Okay, heck yeah. Well, if you're improving, that's pretty sweet. Interesting. This isn't quite the velocity I would expect to see. Let's run it back. Let's see if I can make sense of this. I don't know where it's getting this 1.3 in the z direction from. And it looks like I might be getting this value after it's already calculated. It looks like on collision enter. Is there an on collision exit? Let me check this. Maybe exit would work for our purposes. Oh, wrong way. This velocity I'm outputting, I just don't see where the z is coming from. But anyway, let's try this and see what happens. Okay, so there's something weird going on here. That for sure should have worked. Either something is overriding this value, or I'm missing something. Maybe there's like a set velocity. Alright, I consider two things. One, I'm wondering what object I'm actually hitting here. So let's output the name. Two, let's give this a value of 50. Just to see, because it'll be very obvious if suddenly I have 50 vertical velocity. So let's just check that out. Okay, cool. And it is touching. So what is happening here? Is it a little bit of... Oh yeah, Dom, I found a good trio for... Oh, heck yeah, I did. How'd you find him slash her? Just on Discord, or? Because you needed a third, right? You were just looking for that third one. Okay, so we know it's setting correctly, at least a little bit. And let's set the bounciness to 2 and we'll see what happens. This really shouldn't... This is a fairly straightforward script. I'm not sure what's happening here. But we'll figure it out. We'll get through it. It must just be... weird. Let's see if anybody else has run into this problem. Okay. Looks like other people have had similar problems. Oh, I see. And you were... Okay, cool. So you found two good people. Are they practicing as much as you are? Or are they just not... Or are they just, like, I guess, ahead of you in hours of practice? I guess I'm asking if they're as good as you, is what I'm trying to say. Okay, cool. So it doesn't look like anybody weirdly has tried to do this and had the same problem. It looks maybe like it's just that it... I'm gonna switch this back to enter. I'm wondering when this is actually called life cycle. Let's see when this is actually called. Okay, fair enough, because it's not actually... I think it has something... I think the problem we're running into has something to do with the timing. Oh, that is cool. It's always fun to play with people who are as good as you are. Certainly, I think that'll help you improve. So that's pretty good. Yeah, this is really, okay. So then what? So then we have this... Reset this to 20 again. Let me see that this just works in general. We're going to start taking this problem a little slower just because it's really giving us some trouble here. So I'm going to start testing as I go along. Let me just make sure that this works. Okay, so as far as I can tell, it works perfectly. Are you guys winning some games? Have you guys won together? Tony, sorry, that was a question for you. Okay, it looks like the velocity is positive when it leaves it, so maybe I just need to do this. Oh, dang. Okay, so you guys are pretty good together. You should let me play with you, that way I can act like I'm good. Man, that'd be so cool, Tony. You find like a sick team and you guys all play well together and you're just always playing. I just, for the life of me, cannot understand why. For the life of me, I cannot understand why it's not bouncing. Am I crazy? Let me do this. I mean, I feel like a crazy person here. Literally, I'm taking the velocity and I'm adding more to it, multiplied by that bounciness value. It appears that it's coming in positive for some reason. So I'm just keeping it positive because I want it to be. I don't know. Let me take a look at this. Maybe we can bypass all these problems we're having by just adding force upwards. Realistically, I guess that's probably how I should have done it from the start. My bad. Hopefully you can get up to div 10 and then you can beat Jack or Gilstrap. Let's see if impulse. Impulse sounds like what we'd want. Okay. Oh, my bad. Real quick here before we... Next season, I'm aiming for 26k points. That would be pretty crazy, but I'm sure you can do it if you practice enough. And welcome to whoever just joined. We're making Awesome Apey Orb. Specifically right now, we're making a sort of a tower climb level. It's a platformer. So Awesome Apey Orb, you're in a ball and you roll around. And this level specifically is going to be a tower that you have to climb. And right now I'm just trying to make a bounce pad, essentially. And if you have any questions about that, let me know. So I was going to unrestrict this. That way we can make the bounciness whatever we want. And let's go ahead and set the bounciness to 5 just to make sure that... Actually, that won't quite make sure of anything right now, but anyway, so what are we doing? We're adding force in the upwards direction. Okay. So that's something to remember about Unity. Apparently, I didn't know because I don't often work with physics, but apparently you do not want to set the velocity directly. So what we were doing here, where we were saying rigid body dot velocity, you don't really want to do that. It was working to some degree, but it was not working fully. So you want to use add force instead, which was always an option. I just figured this was also an option, but it turns out that it's not really. So we'll get rid of all that debugging stuff. We'll come back over here. And we'll set this to, I don't know, maybe 25 would be good. We'll test it out. We'll see. And now this is more of a design problem than it is a scripting problem. Now we just need to figure out what level of bounciness is actually going to work for this. Am I going higher? I must be. Not so much. Okay, cool. So now we have these pads. I'd say 25 is good. We can make a level out of that. So now, and feel free to introduce yourself, whoever joined. We're all friendly here. Let's call it pad, just for my own sake. And basically, let's... How do I make... I guess I don't need to make it obvious. It'll become obvious in a second here. Okay, so let's put it right there. And let me go ahead and make a new game object and call it pads, just so I can keep this straight in the scene. Put the pad under it, and that's generally a good thing to do. Okay, and then let's make another one. Let's move it up. And let's make another one. And let's move it up again. And that will sort of be the start there. And then, and if anybody has any ideas for this, I'm swimming a few ideas through my head on how this level is going to work. But right now I'm just going to have it sort of, you jump up and then maybe a rotational jump where you have to do a few rotations. Then I was thinking maybe some sort of timing based event in which maybe there's an object moving back and forth over one of the pads, and if you jump at the wrong time you would jump into that object, something like that, which seems a little bit difficult, but maybe maybe not as much as I'm thinking. So let's push this back here. Let's me put the controllers down so that I can think for a second. And then let's do the rotational part of this. So I guess we're just gonna copy this, move it over, rotate it a little bit so that they know they're gonna start a rotation. Well, let's make it a little closer. We're not trying to make them go too far necessarily. Okay, copy that, move it out, over, rotate it, and this is just going to be a little bit of a, well, I wouldn't call it tedious per se because we're doing the level design, but now would be a good time to ask questions, I guess, because this does not require a ton of brain power. This is mainly just me putting a level out. Then I'm going to make this one, 8 by 8. Then I'm going to copy that. I'm going to move it out again, over. We're just going to do like 45-degree sort of. Rotations here. And we're going to make this a 7 by 7. And we're going to do the same thing. And I think you're getting the point here. Move it out this way, move it out this way, rotate it. I might be making these a little too, it'll be hard to say. We're gonna need to test it. They might not be, like, cause I think the character might bounce like this high. And so it'd be kind of annoying maybe if they were too low. That was 7 already, right? And we'll go to Let's do one more at 5. Probably a good height there. Hard to say though, really, until we play it. For whoever joined, have you made games before? Or are you just here to check it out, or learn how to make one, or what was your, why, I guess what brings you here is what I'm asking. Okay, and then okay, so that's already looking pretty fun, and then let's do, I'm basically just kind of at this point just trying to be mean. Then let's do a couple of these. A couple of these. Then let's do, and this is why you make prefabs, because now you'll see I get to do this pretty easily. A railing. And let me put that railing under this real quick just so that I can't see where this thing is actually in the scene. Okay, cool. So now it's centered. And let's rotate it. And let's move it here and up. That should be good. I just think this will be kind of a fun break during your, oops. It's actually not a pad, but I'll just keep it under pads for now. Rotate this. It actually needs to, I need to change this to the World 4 material real quick. Nothing crazy. Okay, cool. And then let's make it longer. So then you'll land on this railing, which is pointed up currently. It'd be a little bit difficult to get up that. And now it's pointed down. So you'll land on that railing. You'll fly down. Let's grab this pad. You land on another pad. And again, if anybody has any questions or suggestions, you know, because I'm just kind of winging this level. So if there's anything you'd like to see in this level, it's based around the idea of a trampoline, you know. So if you have any ideas for that, let me know. And then really the sky's the limit, so you can kind of throw out anything. I think this level is actually going to be pretty fun. I was a little dubious of it, but I'm thinking now it should be pretty good. Go on that railing, you bounce. Go on that railing, you bounce. What else? And I still wanted to do something where you had to time it like a shutter. So let's do, something like this. And then let's get this railing out of here actually. And then let's create